Welcome to SDQA Wednesday. We have some good questions. Let's get busy. From fall 2017, we have a question about part 4. This is the first question in part 4. And the question is, why is this nitrogen the best base in this molecule? And it all goes back to the fact that this molecule is a derivative of guanidine. This is the structure of guanidine. It doesn't change the fact when we replace an H on this nitrogen with a carbon, or replace this H with a carbon. This is a base that is the same chemically as this base called guanidine. And the big question is, why the nitrogen on top? Well, I'm going to answer that question by protonating the wrong nitrogen. The one she said, why not this one down here, which is secondary over here, which would be the equivalent of this one. I know it's primary versus secondary, but the issue is now, once you've protonated it, using the lone pair that used to be there, you made a mistake. This can't resonate with the other nitrogens. So you would not put the proton there. This one can. You put the hydrogen right here, and you've got 2 more resonance forms, which means you protonated the correct nitrogen. That's the place to put it. This is not. You can't resonate with an sp3 nitrogen. This one's sp2 with a pi bond, can resonate. So that is the answer to that. And yes, guanidine, the part that was in blue before I put the proton on there, is the strongest organic base that you will see in nature. And when it's protonated, it is very stable like this. The blue molecule had a pKb of 0. Please look at a previous video where I said you have to learn that. The pKb of guanidine is 0, therefore the pKa of this conjugate acid is 14. And we need to learn that. Okay. So we've got that. Fall 17. Now down here, similar question. But she's got the answer to her question down here. This here is aniline she drew. And although the lone pair is not needed for aromaticity, the lone pair is resonating with benzene until you put a proton on it. In which case you're going to lose all that resonance that the lone pair had with the benzene, and that's not a good place to put a proton, which makes this a terrible base. I'd rather protonate this nitrogen here, put a proton on it. For the same reason I liked protonating guanidine there, it can resonate with the other nitrogen. If you put a proton here first, that proton does not have other nitrogens to resonate with. So it's not as good as protonating this sp2 nitrogen. So don't put it here first. You're going to go with an imidazole. That's what this is, imidazole. You protonate it first. And then an aniline is a last choice the only worst case scenario to an aniline, I just want to keep reminding you, because this is in a previous SDQA video here, this is the only worse choice than an aniline is a perol. It's not in this molecule. But if it was, I would not put a proton there. This is the worst case scenario. This lone pair is needed for aromaticity. Do not use it for protonation. Okay, and I think we got that covered. Best base here, second best base here, worst base, aniline. Yes, a phenyl attached to a nitrogen is called an aniline derivative. There's the molecule, aniline. And there we go. Moving on to page 2. If it's acid base, I think we would do it in this segment, but it is not. This one deserves its own segment. So we had a short start segment, and we'll come back and look at fall 2020, and it's the roadmap, and she wants us to discuss these. And we'll see you then.